You know that feeling when you buy a new pair of running shoes online, and then for the next 3 months, your feed is just absolutely flooded with ads for more running shoes? Or maybe your music app keeps aggressively recommending the exact same tired playlist, completely ignoring the fact that your tastes have moved on. Well, it's a super frustrating and, honestly, very common digital experience. It really makes you wonder, why do the algorithms that are specifically built to know us so well so often get stuck in the past?
Welcome to today's Explainer, where we're going to look at a genuinely brilliant answer to that exact question. We're diving into a breakthrough academic paper that introduces a framework called CORVUS. And honestly, this research is a total game changer. It fundamentally rethinks how recommender systems learn, making the algorithms that run our digital lives infinitely smarter, remarkably leaner, and incredibly fast at adapting to who we are right now.
All right, Section 1, the recommender system problem, or as I like to call it, facing the twin villains of AI. Let's just jump right in.
So to figure out what you want to see, platforms use an algorithmic framework known as Contextual Bandits. I know, Contextual Bandits sounds a bit like a sci-fi movie title, right? But basically, it's just the mathematical brain trying to juggle two things in real time. It has to explore new items to see if you might like them, while also exploiting what it already knows for a fact you like. It's constantly doing this complex math in the background to predict the highest possible reward, like getting you to click a link or buy a product. But here's the catch. This is exactly where the contextual bandit hits a massive brick wall. It's fighting two giant enemies at once. On one side, we have scalability. If the algorithm remembers every single interaction you've ever made, the data just bloats. The whole system becomes super sluggish and incredibly expensive to run. On the other side, we have non-stationarity, or what researchers cleverly call concept drift. Basically, if the algorithm holds on to all that ancient data, its recommendations get completely stale because your preferences naturally drift over time. I mean, you aren't the exact same person you were a year ago, right? But the bloated algorithm, it totally thinks you are.
Which brings us to Section 2, Introducing the CORVUS Framework. This is all about working smarter, not harder.
CORVUS is essentially the hero of this story. It tackles both that massive data bloat and your constantly changing preferences, and it does it using 3 secret weapons. First up, core set compression. Second, an ensemble meta-bandit. And third, periodic refitting. We're going to break down exactly how each of these works to create a vastly leaner, smarter algorithm.
Let's start with that first one in Section 3, the magic of corsets. Think of this as the ultimate highlight reel.
So the researchers used the technique called sensitivity-based corsets. And to put it really simply, imagine you want to understand an entire football season. Instead of keeping a 50,000-hour unedited video of literally every single second of every game, which, by the way, is exactly what the old algorithms do, what if you just kept a 2-minute highlight reel? A reel that perfectly captures the absolute most critical game-changing plays. That is exactly what a corset does for data. It actually calculates the mathematical importance of an interaction and just saves the essential highlights. Everything else, it just tosses it out.
And you can clearly see the impacts here. Look at that dashed line shooting up. That's your traditional full history, just hoarding data and completely bloating the system's memory as time goes on. But see the solid purple line staying flat down at the bottom? That's CORVUS. By using corsets, it compresses the history down to a strict mathematical limit. The data footprint barely grows, completely dodging that bloat, even after processing 50,000 rounds.
And this leads us to an absolutely staggering number, 2%. Yes, 2%. By round 50,000, CORVUS is operating on less than 2% of the historical data storage. It is literally throwing away 98% of the data bloat. Yet, as we'll see in a second, it manages to maintain the exact same or even better predictive power. It's wild.
All right, Section 4, putting CORVUS to work, battling changing environments. Throwing away data is amazing for saving memory, but how does this actually handle your changing tastes?
Well, that brings us to weapon number 2, the ensemble meta-bandit. Instead of relying on just one single algorithm to guess what you want, CORVUS brings in a diverse team of 3 expert models: LinUCB, linear Thompson sampling, and NeuralUCB. And here's the genius part. Each of these experts is training on its own independent corset, its own unique highlight reel. So they aren't just echoing each other in an echo chamber, they're providing genuinely diverse, independent opinions on what you're probably going to click on next.
And it is so fascinating to watch this adapt in real time. Notice how the usage lines rise and fall across these sudden preference shifts. The system is dynamically handing the baton back and forth between the different base models. There's an overarching meta-bandit acting almost like a referee,
constantly watching to see which model is nailing it at that exact second and handing it the reins. So the moment your tastes shift, the system instantly adapts, smoothly giving control to whichever model best understands the new you.
But honestly, to truly adapt, you kind of have to let go of the past. That's the third pillar, periodic refitting. Every so often, CORVUS just pauses, looks at its core set, and purposefully throws out the stale pre-drift information. It's essentially doing a regular spring cleaning, clearing out the junk data so it can instantly lock on to what you want right now instead of obsessing over what you clicked on a year ago.
So does it work? Absolutely. And here is the undeniable proof of all three weapons working together. This graph measures cumulative regret, which is just a fancy way of tracking how many mistakes the algorithm makes over time. That solid blue line hugging the bottom, that is CORVUS. Across 15,000 rounds and 8 totally abrupt preference changes, CORVUS consistently crushes the traditional baselines. It adapts faster, it makes fewer mistakes, and it proves mathematically that you absolutely do not need all the data to make the best decisions. You really just need the right data.
Bringing us to Section 5, a leaner AI future, where speed meets accuracy. What does this mean for the apps we use every single day? Well, check out this surprising efficiency. You would naturally think that running 3 different complex models at the exact same time would completely bog the system down, right? But because these models are working off those incredibly tiny compressed highlight reels, the entire 3-model CORVUS ensemble runs with a lightning-fast 1.67 millisecond mean latency. It is literally faster than running just the basic Thompson sampling model all by itself.
No way, right?
To bring it all together, the math here just speaks for itself. Traditional methods drag you down because their memory and compute costs scale linearly, meaning the longer you use the app, the heavier and slower it gets. CORVUS completely breaks that curse. It achieves these massive efficiency gains by making both memory and computational costs completely sublinear. It scales beautifully without ever dragging the system down.
Ultimately, this research totally flips the script on the more data is always better mindset that has pretty much dominated the tech industry for the last decade. It proves, beyond a shadow of a doubt, that a well-curated highlight reel beats a bloated archive every single time. And it leaves us with a really fascinating question to ponder. If artificial intelligence can learn perfectly, adapt instantly, and run faster from just 2% of its history, what else in our digital world are we vastly overcomplicating?